Okay, everybody, we're on trig lesson number 2. A very, very important lesson. I know I say that all the time, but basically the difference between somebody who has taken Math 12 and somebody who hasn't is somebody who's taken Math 12 knows what a radian is, all right? It's a way to measure an angle instead of using degrees. And that's what this lesson is all about. Very important if you're moving on in maths and in science, if you're doing engineering and physics and stuff. So we're going to go back to a circle. If we have a circle, center O, this line here is the radius, R. The distance all the way around the outside of the circle is called the circumference. And the formula for circumference is 2 pi r. So the circumference is all the way around. And it's equal to 2 times pi times r. So if I say r is equal to 3 centimeters here, the circumference is 2 times pi times 3 centimeters, which is 6 pi centimeters. You can multiply 6 into pi, but because pi is an irrational number, usually they would just write 6 pi. So that's the distance all the way around. Okay. The radian measure of an angle. So here's our circle. Here's our radius. And this is radius as well. Right? This, when it's not the whole circle, is called an arc. And we'll say arc length. So this distance is equal to the arc length. So if I want to know the measure of this angle here, it is the arc length. Oops, not that. Oh yeah, that was that. Sorry. Doing this at night. Is the arc length over the radius. So it's the length of this here divided by whatever the radius is. And that gives you the measure of the angle in radians. So what are you talking about, Baldwin? Well, if we go to the next page, take our circle again. We have our r, our radius. If you do a full rotation of a circle, that is how many degrees? Hopefully you said 360 degrees. If I ask you the arc length for one complete rotation, in other words, the distance all the way around, okay, that is the circumference, that's what they're saying. And I just told you on the other page, the circumference is 2 pi r. 2 times pi times r, which I guess I could have written circumference here, but whatever. So what we can say is, if I want to measure something in radians, it's arc length over radius. We know the arc length of a full circle is 2 pi r over the radius. So 2 pi is equals 2 pi. And if we have one complete rotation, it's 360 degrees, and 360 degrees is equal to 2 pi radians. This is the beginning of measuring stuff in radians, or the shorthand, as people would just say, rads. You need to remember that 360 degrees is 2 pi. Okay, so if it's 360 degrees, or 2 pi rads all the way around, half a rotation, half of this, in degrees is 180, right? That's half a circle. What is that in rads? That's going to be pi, right? 360 is 2 pi, makes sense. If you divide that by 2, 360 you get 180, divide that by 2, you get pi. And that is the basis. You don't need any of this stuff. I'm going to go to the bottom here. I'm going to do it off to the side here. So know this. You need to commit these to memory. 360 degrees is 2 pi. 180 degrees is pi. That's 90 degrees. Well, just keep dividing by 2. 90 is 1/2 of 180. So 1/2 of pi is pi over 2. 45 degrees is half of 90. Pi over 2 divided by 2 is pi over 4. What is 60 degrees? Well, how do we get 60 from 180? If I divide 180 by 3, I get 60. So divide pi by 3, and that's what 60 degrees is, pi over 3. What's half of 60? 30. Half of pi over 3 is pi over 6. And 0 degrees is 0 rads. You don't have to write rads. If you have no units, it's assumed it is rads. Okay, we'll see that when we do calculator stuff. So when you see sine of 90 degrees, that's in degrees. This is in rads because there is no degree sign. Sign. All right. You could also do this. You wanted to. The common ones usually just write as 2 pi. But if you went 2 times pi on your calculator, 3.14159, you're going to get 6.28318. So this is the same as 6.28318. Keep going. Okay, but obviously 2 pi is easier to remember. You could say pi 3.14159. But these are the easier way to remember them. If you want to convert between degrees and radians, so if you want to go degrees to rads, you multiply everything by pi over 180. If you want to go from radians to degrees, you multiply by 180 over pi. We're going to practice this right now, but you need to remember those. Okay. Convert from degrees to radians, give your answer as an exact line. Okay. So 270 degrees. You could go, so when you're multiplying, you're converting from degrees to rads, you multiply by pi over 180. So that would give you, I'm going to show this out in painfully long ways, but that's okay. Those zeros will cancel. 27 pi over 18. 9 goes into 27 3 times. 9 goes into 18 twice. So this is 3 pi over 2. Okay. There's a faster way to do this. Once you get good at this, I know that that is a multiple of 90 degrees. How many 90 degrees do you need to go into 270? 3. So it's 3 90-degree angles. And if you remember, what's 90 degrees? Pi over 2. So we have 3 90-degree angles, 3 pi over 2. If you look at the second one, 315, that is a multiple. I'll show you the quick way first. No, you don't have to write this. You would just do this in your head. It's a multiple of 45 degrees. How many 45-degree angles do you need to get to 315? I know that it is 7, but if you went 315 divided by 45, you would get 7. So It's 7 45-degree angles. What's a 45-degree angle? Pi over 4. So this is 7 pi over 4. The other way you could do it is to multiply by pi over 180. And reduce the fraction, you'll get that. Now, what they want us to write in values. So this is writing stuff as exact values, 7 pi over 4, 3 pi over 2. But you can also write them as decimals, so 70 degrees. And when you're writing them as decimals, then you actually want to use. So you would go 70 times pi, and literally the pi button on your calculator, and divide by 180, and you will get, there's 10th, so the first decimal, 1.2. And again, no units for rads. Times by 180 over pi, and you're going to get 3.6. Okay, now we're going the other way. Go from radians to degrees. Power of 4. Wow. You should have memorized it, but if you didn't, pi is 180. 180 divided by 4. 45 degrees. 7 pi over 3. Pi over 3 is 60 degrees. We have 7 of them, so it's negative 7 times 60 degrees, which is negative 420 degrees. All right, if it's in decimal form, then you have to use the multiply by 180 over pi. So if I want to convert 1.5 radians into degrees, I go 1.57 times 180 over pi. And that is going to give me 90 degrees. Negative 1.4 times 180 over pi, and I will get negative 80 degrees. Okay, you need to practice this, people. Please, please practice this. Even though I know I'm not going to be able to give you a quiz in class or anything like that, this is super important to know how to do. The questions 2 to 4 is what I'd want you to do right now. If you need to, write out these ones 20 times so you know. You've got to memorize it. It will make your life easier. Okay. And then when you're done that, come on back to this point, arc length. So this is a bit of an application of this. So we've already talked on the very first page that a radian measure, is the arc length. Remember, this is the arc length. I'll call it A. This is the radius, and this is your angle, which we'll call theta. But the angle, the radian measure of the angle, is the arc length A over the radius. So this is the formula. If you multiply the theta up, you get A is equal to r theta. Theta is the measure of the angle in rads, must be in rads. A is the length of the arc, so this curve right here, and r is the radius. You can use this to solve some problems. So a pendulum, 30 centimeters long, swings through an arc of 45 centimeters. So 30 centimeters swings through an arc of 45. What is the angle? What is that? Well, the formula is A is equal to r theta. If I want to find theta, it's going to be A over r is equal to theta. Your arc length is 45 centimeters divided by the radius, which is 30. 45 divided by 30 is 1.5 And you don't have to write anything, because when there are no units, it's assumed it's in rads. But if you want, you could write rads, and you can see that the units, there are no units because the units would cancel. All right. Calculate the arc length to the nearest tenth of a meter of a sector of a circle with a diameter of 9.2 and a sector angle of 150. Okay, so they told us the angle. I always find it helpful to draw a picture. So they're saying you have an angle of 150. It tells us the diameter of the circle is 9.2. The diameter is useless to rads, or radians, radius. The radius is equal to the diameter over 2. So it's 9.2 divided by 2 is going to be 4.6. So our radius is 4.6. Calculate the arc length. So they're asking for, what is this distance here? Well, formula is A is equal to r theta. I don't know the arc length A. That's what I'm trying to find out. But I know the radius is 4.6 meters. And I know that the angle theta is 150. But remember, this formula, theta has to be in rads. So we have to convert 150 degrees to rads before you multiply. You know, you could just go, where am I going to go? Put that down here, 150 times pi over 180, and go like that. And that will give you the right answer, which is 5 pi over 3. 5 pi over 6, sorry. Or you could go, okay, 150. Now I know 30 goes into 150 5 times, right? 5 times 30 is 150. And what's 30 degrees? This is where knowing your angles helps out. If I go back, 30 degrees is pi over 6, and I need 5 of them. So my angle should be 5 pi over 6. This will get you there too, but it would probably give it to you in decimal, which is 2.62. Okay, that's, you can use 2.62, you can use 5 pi over 6, it does not matter. Either one, you can't use 150, you have to convert it to radians. So then I write 5 pi over 6 in here, or 2.62. Multiply all that out. And what am I going to get? 4.6 times 2.62. 12 point, what are we on? Nearest 10th? 12.1. 12.1 meters. So this length here is 12.1 meters. Okay. Last one. There's this. All right. Okay. Circle with center C and minor arc AB. So they're talking about this distance here. That is 5.2. So that's our A value. If angle ABC is equal to angle BAC, ABC. So this angle and this angle are the same. And those are pi over 6. All right. They're both pi over 6. Do you guys remember what pi over 6 is? Unlike the radius. So they want us to find the radius here. Okay. A is equal to r theta. I know A, 15.2. I'm trying to find r. Now theta is actually this middle angle. This is theta. But I know these are pi over 6. What's pi over 6 in degrees? It's 180 divided by 6. It's 30 degrees. What do all the angles in a triangle add up to? theta to 180. So if I go 180 minus 30, that'll give me angle C, which is 120 degrees. But remember, theta has to be in rads. So 120 in rads, well, just like we did 150 as a multiple of 30 degrees. 5 30-degree angles give us 150. How many 30-degree angles give us 120? 4 pi over 6, right? Which would reduce to, if you reduced it down, 2 pi over 3. What's pi over 3? What's pi over 3? That's 60 degrees. This is two 60-degree angles, so you could have done it either way to get to there. So this is my theta, 2 pi over 3. And 2 pi. Okay, now we gotta solve for r. I can multiply the 3 up. 3 times 50. Put the r and 2 pi, and then divide over 2 pi. R is equal to 15.2 divided by 2 pi. Punch a hole in that calculator. Get about 7.3 centimeters. All right, so anytime you have something swinging through an arc, this is most likely going to be the formula you're going to use. The only trick with that formula is your theta has to be in rads. Okay. I would like to do questions 8, 9, 10, 11. Good luck. Email me if you have any questions. Please remember, go over, force yourself to memorize. You can get there. Please go through those. All right. Good luck.